Okay, so the lab we're going to be doing today, guys, we want to just have a look at one of the graphs we talked about yesterday. Okay, we talked about position versus time and velocity versus time graphs yesterday. So what we're going to look at today are the position versus time graphs. We're going to run some of these little toy carts, okay, down the atrium. We're going to mark their positions every 5 seconds. Okay, so we're determining the interval, the time interval, at which the results are going to be recorded. Okay, and obviously the longer we let these things roll, the farther they're going to go. Everybody agree? Okay, so when we're talking about this lab, which of those two things is the manipulated variable, time or distance? Time. Time's a manipulated variable. You're welcome. That's one of the things you need to know for this lab. Okay? It's the manipulated variable because it influences how far this thing goes. Agreed? Okay, we just said the longer these things travel, the farther they're going to go. All right. The lab itself is pretty straightforward. Okay, I'll outline that in a second. Okay? Make sure that your hypothesis talks about the relationship between distance and time for an object traveling at a constant speed. These things do travel at a constant speed. They do not accelerate. Once you set it on the floor, it's essentially going to travel the same speed the entire time. All right. Now, in math, you may have talked about the different kinds of relationships that there can be between two variables. All right. There could be linear relationships. Okay, that means that as one thing goes up, the other thing goes up with a similar factor. Okay, there could be exponential relationships, like that. Okay, that means that as one thing goes up, the other thing goes up exponentially. All right, that would mean that if I was to, let's say, double one thing, the other thing would go up by a factor of 4. If I tripled it, the other thing would go up by a factor of 9. It would always be squared. Okay, that's an example of an exponential relationship. Okay, we could also have an inverse relationship. That means that as one thing goes up, the other goes down. Okay, and the last thing is you could have an inversely exponential relationship. Okay, and it essentially looks like that. Which one of those do you suppose is the relationship between time and position for an object traveling at a constant speed? Yeah, okay. Going to be a linear relationship most likely. You're welcome. That's part of your hypothesis. Okay? In fact, it should be the if part. Now, the and part of your hypothesis as always describes our experiment. Then, in the then part, you should tell me what your graph is going to look like. It might even be right on there. Okay? Everybody with me? All right. For your design, we've already talked about what the manipulated variable is. Okay? Make sure you identify all the variables, several controlled variables. Okay? Anything that could affect, okay, what we're doing, okay, is going to have to be a controlled variable. Now, all of these carts are going to be run in the atrium along the same path. Okay? We're going to measure them all the same way. We're going to have the same people timing and marking. So lots of things are kept the same. All right? Everybody follow me there? All right. So our procedure is going to work like this. I'm going to need one person to be a timer. So just take your phone out there and you can use the stopwatch on your phone. Okay? I'm going to need one person to be the marker. All right? And what they're going to do is just use these little sticky notes because we're going to have this tape measure spread out all the way along the atrium floor. Okay? The timer and the marker are going to walk along beside the cart as it rolls down the atrium. Okay? And every 5 seconds, the marker will put a sticky note down on the tape where the cart was at that 5-second interval. Everybody follow me? Okay? And then if you're not doing the timing or the marking, or you're not the person in charge of the cart, then all you have to do is follow along after and write down the numbers in your chart that's going to look something like this. All right, we'll draw this chart up before we go out there. Okay, so is that pretty straightforward? All right, we're going to run 5 carts here. Okay, actually, you know what? We'll go 4 carts just because it's a shorter class today. We'll go with 4 carts. Okay, now I'm going to need 4 people to be in charge of the carts as well. Okay, essentially your job will be to start the cart, okay, by flipping the switch right here. All right, and then keeping it straight. We're going to run it right down beside one of the seams in the floor, okay, so that you can use that as a guideline. They're straight, okay. Unfortunately, the floor is not. If you've ever looked at our atrium floor, it's got humps and bumps in it, okay, because they did a terrible job on the concrete, okay. It's set too fast on them, or the power trowel guy didn't, I don't know, whatever. It's not level, okay. And so you'll have to, as the person in charge of the cart, slightly adjust the trajectory of the cart as it goes along. If you're a soccer player, you might be good at this. Okay, you don't need to wind up. Okay, this is not a strike. This is like dribbling. Okay, with the soccer ball. All right, not swift kicks. All right, so I'll need 4 people to do that as well. We'll decide on all those here in a minute. Okay, but it's a fairly easy job. So, questions on how that's going to work? Okay, so the chart that you're going to want to have is going to look like this. Okay, so I need everybody to just quickly draw that chart out rough. Okay, obviously you're going to do a better job of that on your lab report. It'll be in Google Docs there, okay, so that it looks nice, but this is what you need. Okay, well, the carts are all numbered, and we'll use toy carts numbers. All right, so the numbers, guys, we're going to use are going to be 7, 9, 10, and 11. All right, so yours doesn't need this 5th row. All right, so the cart numbers are 7, 9, 10, and 11. So we've got our class data here. If yours isn't exactly the same as this, it's not that big a deal, okay? I mean, there's always a little bit of difference in judgment, okay, on there. But essentially, that's what we've got. So we've got about 15 minutes left in class here. I couldn't get any of the computer labs today, so I can't have you have time to do the graphs, but you can at least right now get some work done on the design, hypothesis, okay, and things like that. Get those done, and I'll show you quickly again here in a couple of minutes how you can graph this stuff on Excel, okay, and get your graph that way. Okay, so I'll show you how you graph multiple sets of data on one graph, because we only want one graph done here. All right, so I'll give you a few minutes on that stuff. Okay, a couple of other things here, guys, in terms of what you're going to be asked to do. Okay, calculate the average velocity of each cart. Okay, and that is using your graph. Okay, I do not want you taking the last number on here and dividing by 40 seconds. Okay, I'm not wanting you to do v equals d over t for this. I want you to calculate the velocity of each cart using the position versus time graphs that you are going to build of this data. All right, so that's for step number 5 there in the procedure. Okay, draw your 4. It says runners on here because when it's nice outside, we actually go outside and just have people run. Okay, but we can't do that because it's ugly outside. Okay, and then so yeah, number 1 is using your graph, calculate the velocity of each cart. I want you to show your calculations. Okay, how are you going to get this from your graph? Talked about it yesterday. If I draw a position versus time graph, okay, and my points go like this, and this side's in meters and this side's in seconds, how am I going to get the velocity of my carts? Right. Okay, slope of each line. So how many slope calculations are you going to have to do? 4. You have 4 carts. Okay, so you're going to have 4 lines on your graph, 4 slope calculations. Everybody with me there? Okay, then you got your conclusion and evaluation, same as always. Okay, you don't have to do the class discussion. We'll talk about those when I hand them back after I'm done marking. Okay. All right, so you can get to work on the procedure part, on the design and hypothesis part, and then I'll show you the graphing part here. Okay, so guys, here just a quick demo on how you're going to graph this stuff using Excel. Okay, so I've got all of our class data entered into Excel here now. Okay, so you can see the time is the first column, and then the other cars are the rest of the columns. Okay, everybody with me there? You can't do it in rows. It's not going to work out quite right then. Okay, so set it up in columns like it is here. Okay, and then highlight the uh-oh. Highlight the columns, okay, like so, and then go to Insert. Okay, so that's up here in Insert, right? And then you're going to hit the Scatterplot button, which is right here, right? And you want the one that has only dots, okay? Because then it'll make a true XY scatter plot, right? When you do that, you can see that all 4 cars now are nicely on there. Okay, you can make that a little bit bigger. Okay, we probably also want to use this format here, this box right here, the first one, in terms of chart layouts, because that allows us to name each individual axis. Okay, give it the proper name. You can see here, cart 7, position in meters. All right, so you'd want to title that graph as well. Now remember, if you want to put the best fit line on there, which you have to do for each car, you right-click on one of the points and it highlights them all, and then you put Add Trend Line. Okay, we've already said that this is a linear graph, so that's already checked off. Hit close, and boom, it draws the best fit line for those points. All right, then you'll put in the grid lines. Okay, you do those by going down to the axis and right-clicking on it, and then add minor grid lines. Same thing for the y-axis, add minor grid lines. You'll have all the grids in there. You can do your slope calculations and insert this picture into your Google Doc or whatever program you're using it in for your lab report. Okay, I need to see that graph. The other thing I'm going to want to see, which points or which spots on the graph you used to calculate your slope. Yep, so due date's May 8th, guys.